Today we're going to look at a couple of different operations on radical expressions, primarily adding and subtracting radical expressions, and then later on multiplying radical expressions. So we're going to start here with just some basic adding and subtracting. And the thing to keep in mind is that radicals are kind of like variables when it comes to adding and subtracting. You can only add or subtract and combine when you have like terms. For example, if this was 5x plus y minus 8x plus 5y, I don't think anybody would have any issue simplifying this. Because all you would do is you'd combine the terms that have the x's and the terms that have the y's. Well, really all I've done here is I've replaced the square root of 7 with x and the square root of 11 with y. And so we're going to do the same thing here. We're going to combine the things that have like terms. So I will start by first combining the 5 times the square root of 7, or just 5 square root of 7, and the negative 8 times the square root of 7. To combine these, all I have to do is combine the coefficients. So 5 minus 8 is negative 3. And then I just keep the square root of 7. There's nothing else I can do with that. I don't add that to make it 14. I don't subtract it to make it 0. The radicals stay the same. Just like if I did 5x minus 8x, it would be negative 3x. Now, we'll look at the square root of 11. It's a positive square root of 11 plus 5 square root of 11. And what we want to remember is that in front of the square root of 11, there's kind of like this invisible 1 as a coefficient. So when I add those together, I add the coefficients and I get 6 square root 11. Just like positive y plus 5y would be plus, get the pen there, plus 6y. And so just as I can't combine this any further, I can't combine this any further. So that's actually going to be my final answer, is negative 3 square root of 7 plus 6 square root of 11. I don't need to include the times symbols up here. That's actually just the way that the software does it. That just emphasizes, though, that that's what's being multiplied. And there you go. That's how you would do that. Now let's just take a look at one other example. Looks like this one can't be combined because I have a square root of 5 and I have a square root of 20. Those are not like terms, so I can't combine them. However, I could actually simplify first, and this is going to be a really important technique. So I'm going to keep the 10 square root of 5, and the square root of 20 I'm going to rewrite. I recognize that the square root of 20 can be written as the square root of 4 times the square root of 5. Because 4 is a perfect square factor, that's convenient, because that gives me 2 square root of 5. Now I do have like terms because I have 5's in each of my radicands. Adding those together, I combine the coefficients and I get 12 square root of 5. And that's my final answer. One way that you can check your work for this is you could type in 10 times the square root of 5 plus the square root of 20 into a calculator, and you'll get a decimal. And then when you plug in 12 square root of 5 into a calculator, you'll get the exact same decimal. You won't be able to get it exactly as you want it to be. It'll be a decimal, so you'll have to round it to about 26.8. But that would be exactly the same thing that you'd end up with up here. So that's just a way to confirm that you've done it correctly. So when you're adding and subtracting radical expressions, simplify the radicals completely, and then just combine the coefficients if you have like terms, meaning you have the exact same radicands. This is also true if you had variables in the radicands, it would have to be exact same. So if you could take the square root of 2x and add it to something with the square root of 2x, that would be acceptable. All right, so I hope this is clear. In many ways, multiplying radicals is actually even easier than adding or subtracting them because they don't need to be like terms to multiply. Just like you can do x times y is xy, you can multiply two radicals that have different radicands. Square root of 6 times 5 square root of 3. What I do here is I multiply just the things that are inside the radicals. And so in this case, let's make that black ink there. In this case, I'm going to do the square root of 6 times the square root of 3, which is the square root of 18. And I'm going to take the 5 that's outside of a radical, and I'm going to stick that in front. So I have the square root of 6 times 5 square root of 3 is 5 square root of 18. Now I need to make sure this is simplified. Well, I probably recognize that the square root of 18 can be written as the square root of 9 times the square root of 2. The square root of 9 is just 3. And then 5 times 3 is 15 square root of 2. And so that's my simplified answer. Square root of 2 can't be broken down any further, and that's what we have. All right, let's take a look at another example. You can see in this example here, I have an addition or subtraction inside parentheses, and then I'm multiplying that by the square root of 5. So what I'm going to want to do is I'm going to want to distribute my number that's outside into the parentheses. Before I do that, it's going to become easier, probably, if I simplify my radical first. And so I'm going to keep the square root of 5 because that's already simplified. And then inside parentheses, I've got the square root of 3. That's already simplified. Now think about 75. 75 can actually be broken down and be written as the square root of 25 times the square root of 3. And that's actually pretty convenient because I see something else that's going to happen here. I'm going to have the square root of 5 times the square root of 3 minus 5 square root of 3. Now, still working in the parentheses, what I've created is a situation where these two are like terms. These are radicals that can be combined. It's basically the same as saying, what's 1x minus 5x, and saying that that's negative 4x. That's going to be negative 4 square root 3. And now all that I have to do is multiply the square root of 5, and just like the previous problem, I'm just going to multiply that by the radical. So that's 5 times 3, which is 15. Now I want to double check if that can be broken down at all, but 15 has no perfect square factors other than 1, so that's actually going to be my final answer. If I did this a different way, I could have distributed right from the start, which would have led me to the square root of 15 minus the square root of, now you've got to do 5 times 75, which isn't particularly challenging, but it's a little bit of a big number, and you get 375. What I'd like you to do, if you want to give it a shot, is pause the video and try to get this to match up with this work here. So pause the video and then come back to check your work. All right, let's see how it went. So there you go. There's your work that will support that there. All right, we have one last problem to look at. Here we have a 2 square root of 5 minus 4, and we're squaring that. Probably the easiest way to deal with this is to remind ourselves of what it means to square something, which would be, let's erase this real quick here, which would be to set it so that it's multiplying itself. That's 2 square root of 5 minus 4 times 2 square root of 5 minus 4. And so what we have here, we have set up a multiplication by probably the FOIL process or distributive property. So what we're going to do is we're going to multiply the 2 square root of 5 times each of those, and then the negative 4 times each of those, and then we'll see what can happen. In the first problem, I get 2 square root of 5 times 2 square root of 5, which is 4 square root 25. In the second one, I have 2 square root of 5 times negative 4, which is negative 8 square root of 5. Then the inside is negative 4 times 2 square root of 5, which is another minus 8 square root of 5. And then at the end, I've got the negative 4 times a negative 4. Remember that a negative times a negative is a positive, and 4 times 4 is 16. Now I want to combine what I can. The square root of 25 actually works out nicely. That's actually just 4 times 5. I have like terms in the middle here. They're both square root of 5. Now they're both negative, so they're not going to cancel out. It's going to become a larger negative, minus 16 square root of 5, and then plus 16. Multiply out the 4 times 5. And then the 20 and 16 can be added together to give me 36 minus 16 square root of 5. And that's the answer that I need. That just about sums it up. So anytime you have any thing set up like this, where you have radical expressions, binomial times a binomial, or even larger than that, you can use the distributive property, FOIL method, Punnett square, whatever you want to call it, and simplify each individual piece, combine like terms, and then you'll have your answer. All right, hope this makes a lot of sense.